class. I'm glad you're there. I want us to look at how we can resolve 3 or 4 or more forces acting from a point. Remember, in our last class, we dealt with how to resolve 2 forces acting from a point, maybe at an acute angle or at an obtuse angle. But today, we have more than about 1, 2, 3, 4 forces acting from a point at different angles. Now, the first thing we will do is to resolve them in 2-dimensional plane, which is x-axis and y-axis. How do we do that? We can consider this one first. Assuming we take this one and complete this side. Of course, we have an angle here, or a triangle. So if we can bring out this triangle and represent it to give us a clearer picture of what we are doing. Now, this is this force now. This force F1. Look at it here. Now, this theta, this is angle. Okay. There are 2 sides now, either this side or this side. So if we are resolving along the x-axis, meaning we are resolving along this, so we have this. If we have this, it will take us this side and this side. Looking at the trigonometric ratios we have, which is, we can have SOHCAHTOA. Looking at it, this side is the hypotenuse and this side is the adjacent. Remember, any side facing the angle is your opposite. So since we are not dealing with this, we are just concentrating on the horizontal axis and this. So hypotenuse and the adjacent, and of course it is only cos theta that will give us that. So we now have cos theta is adjacent, which is x all over hypotenuse, F1. Now because of that, if we resolve along this x-axis, we are going to have cos theta here. Now, if we want to resolve along the vertical axis, we can put it here, or we can say, let's here be y. If here is y, we can now have opposites and the hypotenuse. So it's only sine that gives us opposite and the hypotenuse, the ratio of opposite and hypotenuse. So we can now have sine opposite, which is y, sine theta, which is what opposite, y all over hypotenuse is F1. In other words, if we want to resolve along the vertical axis or the y-axis, we can have sine theta here. Having completed this, let us now take 1 or 2 calculations to help us in what we are doing. Having this diagram on the board, we said using the diagram as a guide, calculate the resultant force and the direction of the resultant. So if we have a problem like this, all we need to do is resolve them using the formula we established earlier. Now, after resolving them, you will now have we will resolve this, take the total of all the forces along the S component, we take the total of all the forces along the Y component. Once you do that, the next thing is to draw them. If it gives you a positive value, you can have it like this. If assuming we have negative, by the time we finish it, let's see what it will give us. However, all the forces along the X component will be here. All the forces along the Y component will be here. So once we do that, we complete this side. Draw a diagonal. The diagonal here will now give us the resultant force. While this one here will give us our direction. So let's take a look at this. Now, from what we have said so far, all we need to do is to list out all the forces given to us in that order. So the first force is 20. We can have 20. Let's say 20.0. We can say 20.00. You take care of the decimal places. And the second one is 10. We can say 10.0 or 10.00 as the case may be. The third one is 50.0. And then the fourth one is 5.0 in this order. Now remember that if we are solving this, these are angles. Remember, this one is corresponding to this. So we have 30.0. The 25 is corresponding to 10. We'll have 25.0 here. 35 is corresponding to 50. We can have 35.0 here, while 45 is corresponding to 5. So we have 45 here. Now, the point I want you to note is that these forces do not make angle with this side. No. Even if from WAEC question or JAMB, if you are given angle here, please, from here to here is 90. So whatever angle you have there, subtract it from 90, it will give you here. Okay, so let's continue. If you want to resolve all the forces along the x-axis, what we will do is we can close this side. Everything that falls, of course, we know that positive, this side is positive side. So whatever that falls here, of course, 20 and 5 falls within the positive axis. Now, while 10 and 50 fall within the negative axis. Now, for the y component, if we're resolving along the y component, we close it like this. Of course, this is negative y. Everything down here is negative, whereas everything up here is positive. So, from here, we'll take the first one. Here is, since we're dealing with the horizontal latitude to the x-axis, here will be plus, this side plus, this side negative, and this side negative. So we'll now take the first one. 20 cos the angle there, 30, will give us. The second one is, okay, let's finish this one first. Cos 30 is 0.866. So we now have 20 times 0.866, which will give us that 20 times 0.866. From calculation, it will give us 17.321. Now, the second one, of course, we have entered here. It will be negative. So, minus 10 cos 25, which will give us minus 10 times cos 25 from the fourth figure table from calculation will give us 0.906. So, of course, if we multiply by minus, it will give us, let me write down here, minus 9.06. Remember, put your unit in here. The second one, the third one will give us, of course, this is where we add up, minus 50 cos the angle there, 35, which will give us minus 50 times cos 35 by calculation will give us 0.819, which will give us a minus 40 point, let me write down here, minus 40.958. The last one will give us, of course, this is what we got. Because of this, we can have 5 cos 45. 5 times cos 45 from 4 figure table will give us 0.707. Multiplied by 5 will give us 3.536. So at the end of the day, we add up all this. Now, having done this, let us now look at the vertical components. We erase these signs. So if we look at the vertical components, everything here will be positive, everything down here will be negative. So we have positive here, negative here, negative here. So we have the first one, 20, remember sine. 20 sine 30 will give us, sine 30 is 0.5. So we have 20 times 0.5, which will give us 10.00. Okay, but since this we're dealing with 3 dp, so we'll make it 3 dp here. So the second one will give us, and of course, this is where we are, to give us positive also. So we have 10 sine 25, which will give us 10 times sine 25 from 4-figure table will give us 0.423 multiplied by 10 will give us 4.23. We can put 0 here. Okay. Now the third one now, which is this, remember we have entered the negative region. So we have minus 50 sine 35, which will give us, remember your minus sign, put your minus 50 times sine 35 from 4-figure table will give us 0.574, which will give us, multiplied by this, your minus will jump out. Everything will be 28.679. Okay, the last one, which is here, remember this negative sign. So minus 5 sine 45 will give us, you bring out your minus here, minus time, sine 45 is 0.707 by 4-figure table. So minus 5 times this will give us minus 3.536. Okay, now we add up this, and this. So it will give us the summation of all the forces along the y. So let us start from here. 17.321, remember this is minus. So 17.321 minus 9.060 minus 40.958 plus, this one is now plus. So at the end of the day, everything here will give us minus 29.197 Newton. So all the forces along the x component will give us this. Now all the forces along the y component, 10 plus 4.23 minus 28.679 minus 3.56. Everything will give us minus 17.985 Newton. Okay, so at the end of the day, we have been able to resolve all these forces into two components, x component and the y component. Now, all we need to do is we represent them pictorially. Remember, this our Fs is negative, this one is negative. So remember, when I have this negative, we have negative here. Okay, so here is our Fx, which is minus 29.197 Newton. The y is minus 17.985 Newton. So all we need to do is complete this square, draw a diagonal here. Now, this is the direction now, alpha. So here will give us our resultant. So using Pythagoras theorem, we now have r squared is equal to all the forces along the x component, fx squared, plus all the forces along the y component squared, which will give us, and of course r itself is square root of this. So we now let us take it straight. Square root of the fx squared plus fy squared. So r will give us fx minus 29.197 all squared plus minus 17.985 all squared, which will give us, of course, we will take the square root of those values there. We will now have square root of 29 will give us 852.465 plus square root of the square of this piece will give us 323.460. When you now add the two, we have that the two will give us 1,175.92. So if we take the square root of that, we now have that R will give us square root of 1,175.92 will give us 34.29 newton. So we can bring it here 34.29 newton as a resultant. Now we can take our direction, which is the second question. For the second question, for the direction, we have tan alpha equals, and of course, this is our opposite now. This side facing the angle. Opposite, which is the y-axis, all over the adjacent, which is the x-axis. Tan theta is Fy all over Fx, which will give us. Now, at this point, you don't consider the negative sign now. Pick only the numerical values. If you pick only the numerical values, for this, we now have 17.985 all over 29.197, which will give us 0.616. Alpha is equal to tan inverse of 0.616. Alpha will give us the tan inverse of that is 31.63 degrees. So the direction now is 31.63 degrees along this fx axis. Now, if you want to find this other one now, you can now say or 90 minus 31.63, which will give us 58.37 degrees. So there are two values down, 31.63 degrees and 58.37 degrees. So for this first one, we now see that the resultant of f and fx and fy is this at this angle to the horizontal axis, or we now say 58.37 degrees to this. So we can have here as 31.63 degrees, or we can have here 58.37 degrees. So this one can also be done. If we swap these values, let's say instead of taking tan theta, tan alpha is fy, all the forces along the y-axis, all the forces along the x-axis. So if we take it, turn it upside down, put your fx here, put your fy here, at the end of the day, this is the value we are going to take. Alright, so let us take another one. Okay, now we have, this is the assignments you will help me do. The same procedure we did this. Now we have 25 rating, 15 rating, 12 rating against their corresponding angles. So we are asked to calculate the resultant force and the direction of the resultant. And remember, if you look very well, discover that no force is given here. Because no force is given here, do not panic. All you need to do is continue. Just as we have 4 forces here, all you need to have is just 3 forces. So resolve here, 1, 2, 3. Leave it. That means this fourth one will not be there. you will carry all the procedures from here to here. The fourth one will not be there. That is the only difference between what we did before and what you have now. Please do it. I'll need the answer in the comment section below. Please do not forget to share this video with your friends. Hit the like button because that is what motivates me to create more content for you. Thank you.